Hi, I'm Paul McLellan, the editor of Cadence's Breakfast Bites, and I'm here with Erik Marinissen of imec. So, Erik, tell me a little bit more about what you do at imec.
At imec, I'm the designated test and DfT guy. Actually, I've been that for my whole life. I started out as a master's graduation project from when I was at university at Philips Research. I liked Philips Research, stayed at Philips Research, started liking test and DfT as well. And that became NXP Semiconductors, and then about 10 years ago I moved to imec. And I've been there ever since, always on test and DfT.
So I gather we've got a joint project with Jiangao doing cellular tests. So
Yes.
Tell us a little bit about that.
That's actually the second project I'm doing with Cadence. So we started out, when I started out at imec, I was hired to work on 3D stacked ICs, with TSVs and microbumps and stuff. And the DfT for that we have developed together with, and the tool flow we have developed with Cadence. And that was like a 5-year project where we intensively worked together and had a lot of good results. Then we felt that the problem was for that moment solved, but we liked each other so much and the results were so beneficial that we decided to continue in another project, and that was cellular test. I had some background in that from my Philips time, and I could leverage that in the new project with Cadence.
So is this particularly oriented towards automotive, or?
It is actually oriented to every market that needs high quality for an affordable cost. And automotive is definitely a market like that. It is not difficult to do high quality if you have an infinite budget, like NASA for the space shuttle, but there's only a few space shuttles. Automotive is difficult because you still want high quality. You don't want your airbag to open while you're driving and cause an accident while nothing is necessary to open the airbag. But it's still a high volume market, so it's still cost sensitive. And that is actually what cellular test does. It tries to improve the test quality by looking for library cell internal defects that in the past were just tested by luck, by coincidental. And so now we explicitly go after them, and that should reduce the number of test escapes and therefore the quality of the chips at an affordable increase in test time.
So that actually looks at the layout inside the cells.
Yes, so we do analyze the layout inside the cells. That's an expensive operation because we go very detailed over every layout, every cell layout. And we do that for all library cells, for all defects in the library cell, for all patterns. We find out which patterns detect which defects. So that is sometimes days long of simulations. But that is an effort that you only need to do once on the library, and then for the hundreds of designs that are made for that library, you can reuse the benefits. Yeah.
So is this a very theoretical thing, or is this something that's actually going to be incorporated into the Cadence product line?
It's actually in a few days going to be released as Modus 19.1. So it's going directly in Cadence tools. We work intensively together with the Modus R&D team in Endicott, New York. We work on their servers. We have more than weekly calls with them to talk about new versions of the software and new algorithms that we incorporate. And so it's not just an academic research project. It also has to have some research components, to publish papers and to get the PhD from Jen out. But it's very practical in the sense that we directly deliver tools that are in the hands of customers.
So it sounds like a great project, really, cooperation between Cadence and imec and academia, Technical University of Eindhoven in this case.
Yes, and that is typical the role of imec, position themselves in between the industry and academia. And yeah, that is basically what all imec projects do, I think, yeah.
Oh, that's great. Well, Erik, thanks very much for your time.
Thank you.